So let's remind ourselves of how to write up an experimental report. Remember that we always need to keep in mind that there are two things in science. One is a theory and one is a fact. Facts are undisputable and they are observations. So an apple drops from the tree to the ground. The theory behind that is our best explanation for what we observe right now. For example, we can say it falls to the ground because of gravity. No one's ever seen gravity. There are no little green men jumping up. There's no lines. There's nothing like that. We've never seen gravity. But the theory of gravity explains our observation of the apple falling out of trees. It's our best explanation for what we observe. Scientists, when we talk about a scientific theory, scientists have interrogated it and it holds value and validity. Scientists conduct experiments to determine facts and theories. They gain a better understanding of the world around us. How do they write that up? So, the first thing, every experimental write-up should have an aim, a method, apparatus, a method, observations, results, interpretation of results, and conclusions. So, how do you do an aim? An aim must always start with the word to. Examples of aims are to see if white or dark chocolate melts first, or to determine if a nut or an orange falls faster. What is the difference between an aim and a hypothesis? A hypothesis must be a statement. So, white chocolate melts faster than dark chocolate. Doesn't matter whether it's true or false. A hypothesis is what we think is going to come out. A nut falls faster than an orange. True or false? Not the issue. It must read as a sentence of proposed trueness. Some experiments start with an investigative question. Would white or dark chocolate melt first? Or would a nut or an orange fall faster? List your apparatus. So your apparatus is often listed. Sometimes you'll draw a picture for that. So for, let's say, the chocolate experiment, you'd use a double boiler, a gas stove, white chocolate, dark chocolate, and a stopwatch. For the nut and orange experiment, maybe you use the nut, an orange, and a stopwatch. You then describe your method. Remember that your method must be written in the past impersonal tense. You've already done the experiment, so it's in the past. Impersonal means we don't care about you, we care about the experiment. So the water in the double boiler was boiled on the stove, etc. Note, you must repeat your experiment at least 3 times to ensure that your results are reliable. Everything except the type of chocolate was kept exactly the same. So you're going to find your independent variable is the type of chocolate. With the nut and the orange, let's look at a sentence. The time was recorded, past impersonal. We must repeat to get reliable results. And everything is kept the same except for the object being dropped. What are your observations? Observations are what you perceive with your 5 senses: smell, taste, touch, sight, and hearing. And they also get written in the past impersonal tense. Observations are not numeric data, in other words, no numbers. So something like the chocolate smell filled the room, both chocolates melted when they were touching the container, the nut and the orange seemed to make a noise when they hit the ground, the orange split open. Some of them may land up being relevant, some of them not, but they are all your observations when you do the experiment. Then you put your results in a table, and your table needs to have a heading, and these two don't really have a heading, so that's a bit of a problem. Time taken for white and dark chocolate to melt, time taken for a nut and an orange to fall to the ground. Time 1, time 2, time 3, average. Notice my units are in the heading of the table each time. Also, notice that you present all the data and show the averages. You don't just show the averages. Then you get interpretation of results, and this is where you do any calculations and you link back to theory. So, if you've got graphs, if there's some theoretical information, maybe you did some research as to why one type of chocolate melts faster than the other, or vice versa. So, you show your calculations of the average times each time. Perhaps the forces between the particles of white chocolate are not as strong as the forces between the particles of dark chocolate. Or you try to come up with a theoretical explanation, your best explanation for what you observed. Both average times were very similar, suggesting that both objects experienced the same acceleration. Then you've done some research. This corresponds with the gravitational acceleration on Earth being 9,8 meters per second squared, regardless of what is falling. Remember that you are going to put your graphs in. This is a little joke. It's from a university graduate who says this is what your actual data looks like. You try and make it look like it was a pretty straight line, but when you give it to the teacher thinks, no, maybe it was a curve. And then when they look at it, when somebody is moderating it, they think it's all over the place and means absolutely nothing. The point is that we try to bend results into what we hope they are going to be. But sometimes it just isn't so. So we need to keep a wary eye on our own biases when we do experiments. And then finally you do a conclusion. The conclusion has to link back to the aim, the hypothesis, or the investigative question. So you need to talk about white chocolate melts faster because the aim was to determine whether white or dark chocolate melts faster. The aim was, does the nut or the orange fall faster? Sorry, that's the investigative question. Both the nut and the orange fall at the same rate. So that is the layout of an experimental write-up.